will demonstrate using a standby database in read-write mode. The way you do it is you convert it to a snapshot standby. This allows you to run destructive testing on the standby. You could be testing an application upgrade, you could be testing your DR site with your DR application servers connecting to the database and running transactions. So all those changes to the schemas, transactions can run on the standby without affecting the primary database. The primary database can continue running. The primary database can continue generating transactions and redo logs, shipping them to the standby, but the standby being open in read-write mode will not apply the transactions it receives from the primary, it just save them on disk. So once you finish your testing in your standby, you revert it back to a normal physical standby and it will sync back with the primary. So I'm going to demonstrate that feature here. So this is my standby. You can see that it is started recovery, is receiving archive logs from the primary. This is my primary. I'll just generate some more archive log. Okay. So you can see when I generate transactions and archive logs from the primary, they get shipped and apply the standby. So this is normal situation. I'm also going to use a PDB here. Just see if the table exists. Drop table. Okay. So this is the DDL statement. So as soon as the redo for that DDL statement ships to the standby, it gets applied. I do not have to actually force a log switch at the standby. It is because it is continuously applying the redo it receives. But if I want, I could also force a log switch. So archive log will force a log switch and ship the log to the standby. But the standby anyway is continuously applying the redo receives. Now I want to convert my standby to a read-write database, which basically I'm simulating a primary database. So there is one requirement for that. You need to have a DB recovery file dest configured. It should exist. There should be enough space for two types of files that will get created there. If you are archiving archive logs on the standby, the DB recovery file dest, those will continue to be written to the DB recovery file dest. If your standby archive logs are not being written here, they'll be written somewhere else, which is fine. But the second type of file is flashback logs. When you open your standby in read-write mode, that is as a snapshot standby, it creates an implicit recovery point, a restore point, and the flashback logs for that will be returned to your recovery file dest. Your standby database does not have to have flashback on enabled at the database level. All it needs is the recovery file dest. Flashback on is optional. You can have that because you might, in your normal course of behavior of your transactions from primary to standby, in a real situation you might want to flashback both your databases. So you might have flashback on in both databases. For this requirement that you want to open your standby as a snapshot standby in read-write mode, you do not have to have this enabled at the database level, but you do need to have recovery file dest enabled. Okay. So now I'm going to open my standby database. Obviously, if I want to open it in read-write mode, I have to cancel recovery. Let me dash because I have a few problems with the keyboard, so I need to just properly run the keyboard. So first thing I do is cancel recovery. So you can say here I have done a cancel recovery. Okay, so recovery is no longer running in the standby. but my primary can continue generating transactions. So my primary is generating transactions, the standby is receiving the archive logs and storing them. Let me just verify my primary database. Sorry. So at my primary I had one table which is a normal production table. Let's assume this is a normal production table, and during my standby testing I'm going to do transactions against this normal production table, but I want to discard all those changes when I revert to a standby. So first thing I do is cancel the recovery of the standby. Then I convert it to a snapshot standby convert. So when I issue the convert to snapshot standby command, what happens here? It creates a guaranteed restore point. See, when you convert a standby to a snapshot standby, there is a guaranteed restore point implicitly created. You do not have to create your own restore point. One restore point is automatically created for you. Okay, then it just kills some processes so that it doesn't allow the file recovery, the archive log recovery to be continuing at the standby. Clears all the online redo logs at the standby. Okay, and so it has completed conversion of the standby to a snapshot standby by simulating it to be a primary. Okay, it became a primary. Then I open the database in read-write mode. So this is normal. It's as if it's a primary database. I can open a database in read-write mode. Okay, this is fine. So I open the database in read-write mode, and these are all current log files. And of course, because they did a let me just show you that simulated a recovery and a reset logs. So it simulated an incomplete recovery and reset logs. So when I open the database in read-write mode, it goes back to sequence number 1. Although before that, the sequence numbers were very high, 221 for thread 1 and 202 for thread 2, because my primary is a rack database. So here on the standby, my sequence numbers got reset to 1. Let's just show that here. Okay, so your standby got reset to 1, although it was 200 and 222 from the primary. I think you can ignore all this because I'm not because these are normal messages. You can just ignore these messages, but what is important is the sequence got reset to 1. Okay, now I can open my pluggable databases also. Okay, so the pluggable database is also open. Now I can have my application servers and users at the DR site start running transactions on this database. So for example, I'm going to use a sys account, but normally you would be using your application schema account or a user account to do transactions. For simplicity, because I don't want to open another client, another network connection to the standby, I don't have much screen space here. So for simplicity, I'm using the sys account, but you would normally use a normal user and connecting through an application. So this is the same number of records that were created at the primary. This is a production database at the standby. What I could do is I can do destructive testing. I'm sorry. So I've created another table, the standby XYZ. I can actually generate archive logs of their own at the standby. So you can see a sequence number 2 got generated at the standby. So this sequence 2 is for the snapshot standby, not for the primary. So when the snapshot standby starts resyncing with the primary, it'll go back to the old sequence numbers. So how does it know that? Because there's a flashback, there's a restore point created for for flashback support. Let me just show you that. Okay, so this is the restore point that got created automatically when I opened the standby as a snapshot standby. So you can decide the timestamp and all the information. If I go to that location, so these are the archive logs that got these are the flashback logs that got created at the standby. So I can continue transactions at the standby. Oh, I need to connect back to the PDB. So I've created, I've truncated the ABC table at the standby. I've created 2 more tables at the standby called. So here I truncated the table. I created another table called XYZ, and I also created another table called another table. So the standby has been running transactions. So let's say the users have run these 3 different transactions: truncated the ABC, created XYZ, created another table, done some DML, maybe. I could even have dropped ABC. I just did a truncated insert, but I could have, for my distribution, I could have dropped the table. You can do anything you want. You drop tables, you create new tables, you create new store procedures, you create new users. Everything is possible as long as your restore point and your flashback log support enough. Have basically your recovery point and has enough space to create the flashback logs for that guaranteed restore point. So now let's say my user finished testing. I want to revert the standby back to physical standby and convert to the primary. Remember on my primary, let me just go back here. Okay, so the primary is still shipping archive logs. They're still coming to the standby, but they're not being applied. At the standby, if I were to connect to the root, so standby is running in this sequence number. So this is, so standby is running a different sequence number, right? Sequence number 2 got archived. Let me just, so standby sequence number 3 got archived. So uses the finished testing. Now we want to convert the standby back to the snapshot standby, the read write snapshot standby back to a normal standby. So what we do is shut down the standby because it is currently in read write mode. Ideally we would even shut down all the application servers and users at the DR site or at the standby site. They finish the testing, they're going home. So now the DB has to revert the standby to sync back with the primary. In the meantime, the primary has been generating more archive logs. Okay, so the primary is continue to generate transactions. So the standby is shut down now. This is like a normal shutdown. This is as if it's a primary database, standalone database. It's shut down. Now what you can do is, let me just show you one more thing before. Okay, so I am going to convert it to a physical standby, but let me just look at what is the status of this database. I have mounted, but I'm not opening, and I'm not doing recovery. In fact, you can see here itself, it's still a snapshot standby. It's not a physical standby. If I were to scroll back many lines when it was a physical standby, when I converted from physical to snapshot, and earlier it was a physical standby here, right? When I start up the standby database, it was a physical standby. So right now it still identifies itself as a snapshot standby. So I can check the status here by this query. The control file has become a current control file, not a standby control file. It's a primary control file, but the database role is snapshot standby. So I'm going to convert it back to a normal physical standby. Okay, so it's going to terminate all sessions, and now it's recreating the standby redo logs. You can see that beautifully here, and it has, okay, let me just go back once this command returns. Okay, so as soon as I issue the command convert to physical standby, it starts running that, kills sessions. It deletes all the archive logs that it generated. Remember, I showed you a few archive logs were generated the standby, sequence 2, 3, 4, 5 and all that. Sorry, sequence 2, 3 and 4 was the current log file here. Okay, so those archive logs that it generated the standby get deleted automatically. Then it does a flashback restore. I had showed you there's a restore point that got created. There's a restore point that got created here, and some flashback log files that got created. So those also get deleted. In this case, I had very few transactions, just a few flashback logs. After that, it recreates its standby log files. Okay, so then it basically any offline files, that is files belonging to other PDBs, also matter. So all the files belonging to multiple PDBs get converted to standby, to being in a standby role for the database. So now it is converted to a physical standby, but it's still not doing recovery yet. So what I should do is I should stop and start the listener and restart the database. Did I exit? Okay, so I go back in. Okay, so if I were to run the same query after the conversion to physical standby, if I were to run the same query again, sorry, okay, now the control file is a standby control file. Remember earlier when it was open in read write mode, it was the current control file as if it's a primary. database role is revert to physical standby. It was a snapshot standby earlier. So I just do a shutdown and start up. So then it will automatically begin recovery again. Okay, so the instance has got shut down, the standby at the standby database server. I'm starting it up again. So now it's actually a proper physical standby, and it has to continue recovering from the primary, and it has already done a flashback to the point in time where it was a snapshot standby. So it's now ready to apply any archive logs that got generated from the primary which were not applied earlier. So here you can see it automatically starts the recovery process. Okay, and you can see here all the archive logs that I received from the primary from two instances, instance 1 and instance 2 of the primary rack, have been applied automatically. Okay, so now it is in sync with the primary. So that's a normal status for a standby database. Now let me go back to the primary and see what happens. I created a few tables, I truncated and made changes to the ABC table. Okay, just to show that it is applying from the primary, I'll just do some more transactions here. So you can see it is recovering. New archive logs from the primary are being recovered. Now I'll just go back and look at that PDB. So this table still has all those rows, although here I had truncated the table and recreated with only 4 rows. Does this table exist, XYZ, that got created as standby? No, it does not exist. So any changes that I made as standby did not propagate back to the primary, because the standby being a snapshot standby was isolated from primary. It was not shipping transactions from standby to primary. And once I converted back to physical standby, once I converted back to the physical standby here, it did a flashback and then started applying archive logs that came from the primary. So that's a beautiful way of opening a standard database in read-write mode for any sort of destructive testing, for application upgrades, for DR testing, schema upgrades, to test some data which is corrupted or whatever you want to do. Open the standby database in snapshot standby mode. Ensure that you have enough space for in the DB recovery file list for the flashback logs, and if you are writing archive logs to the same location, you also have enough space for the standby archive logs that got created, right? There were a few archive logs that got created as standby during my testing, so let me just go back and see where they got. So those also got deleted when I reverted back to physical. So your DB recovery file list must have enough space for archive logs generated as standby and for the flashback logs. It does not have to be flashback on at the database level, because the restore point creation and deletion is automatic. If I were to query for the restore point here again, it got deleted, right? This was the restore point. Let me show you the restore point that got created as standby. It got deleted. Let me go to the location where flashback logs were created. All the flashback logs got deleted also. You can see that here. Deleted archive logs, and then deleted flashback logs, then reset the standby redo log files. So that's a beautiful way of using a standby database for read-write testing. Thank you.